I realise I'm talking immediately after lunch, so everyone is just going to be sleepy. But never mind. My name's Owen. I'm from the MathWorks, or MathWorks. I'm not quite sure if there's a third name. And you may be familiar, you may not. We make a product called MATLAB and Simulink, which is a technical computing and model-based design tool. You're upsetting me. And for a long time, it's been an educational tool. Pretty much all engineers at university use MATLAB at some point. Whether they like it or not is another matter, but they use it. Some of them get some experience with Simulink, but then if you go into engineering industry, Simulink is very widely used. I mean, most cars nowadays, all of the processors in them are all programmed from Simulink. Most of the big auto manufacturers are sort of some of our biggest customers. Now, students in the industry, they've been big sort of markets for us for a long time. But more and more so now, particularly with this low-cost hardware that's coming out, we've seen this kind of opportunity to offer what it is we provide to hobbyists, to makers, to you guys. Now, obviously, a lot of you may be engineering students as well, or maybe were, so that fits nicely, but not necessarily. So, all I wanted to do here today was just give you a quick introduction to the kind of thing you can do on a Raspberry Pi using Simulink. And I'll start actually just by saying, some of you are familiar with MATLAB and Simulink and you think it's this piece of software that costs many thousands of pounds and there's no way you'll ever be able to afford to use it, that is true. If you are a commercial company trying to make a product that you're then going to go on and sell. We've always offered a student version for a fairly reasonable price. I think it's £55 at the moment. We are now moving over the next month or so, I don't think this is official yet, but it is happening, to also offer a home use version. The exact same version as the student version. It does pretty much everything you'll ever need it to do. It costs the same price. It pretty much just is the student version for £55. And everything that I'm going to show you here today, which isn't as impressive as it could be, but I will show you the video of doing the impressive stuff, you could do with that version of the software. So if you think it might be useful to you, feel free to come and have a chat with me, or send me an email after the fact, and we'll see if there's any information I can give you. So this is a little robot that we've got on the table here. It doesn't really matter whether or not you can see it. It's not going to do anything particularly impressive, but I'll just explain to you a little bit what it was. It's a robotic ball boy. We took part in an event last week where we had to form a link in a chain that would, we had a table, and on one side of the table, the previous table to us would pull on a piece of string. That then had to set off something on our table, and we had to do something cool and end off by pulling a piece of string on the other side to set off the next table. And this went round at the Cambridge Chord Exchange for about 10 minutes, because most of them just got stuck and people had to draw things to make it actually do it. And our link in this chain, we decided we'd create an autonomous ball boy. So when the piece of string got pulled on one side, in fact I'll show you the video in a minute, but this is the robot we made. So it's got a camera on the top. There's just a conventional webcam. It's not the Pi cam or anything like that. It's just the conventional webcam plugged in over USB, sitting on the top there, and we use that to do some fairly simple image processing. The robot goes off and tries to search for a tennis ball, which is looking for the roundest, greeny, yellowish thing in the image. And then where that is in the image, it can then use to steer itself and drive towards the ball. Once the ball gets close enough, it closes its jaws, and then it spins around and starts looking for Andy Murray. When it sees him, it drives to him, gives him the tennis ball, and then through some convoluted mechanism of giving Andy Murray, a photo of Andy Murray, wasn't really that, giving him the tennis ball, through that convoluted mechanism, we pull a piece of string and the next tee goes off. So that's what this was. The interesting thing about it is the actuators and things, the motors, the little touch sensor on top for starting it and stopping it, that's all just Lego Mindstorms equipment. I'm sure some of you are familiar with the Brick Pi. The Mindstorms interface, so you can plug the sensors into your Raspberry Pi. And what's interesting there, and something that a real point that I wanted to get across it, is that the Simulink package for Raspberry Pi does not support the Brick Pi. However, it's very, very easy to make it. it supports BrickPy, and that's something that I want to show you guys. So we'll move away from the picture now. If you are not familiar with Simulink, this is Simulink. It's just a block diagram programming tool, graphical programming tool. So you can see all various different types of blocks there. That block there, see that? Is the video capture block. Any V4L video source on the Pi will be supported by that block, because it just uses the standard C code in the background. And then coming in from that, we've got a couple of blocks to do image processing, draw some markers on the video, and then redisplay the video to you. This is all done over a network and displayed locally on the laptop machine. You can also, if you do have a HDMI screen plugged in for your particular purposes, you can display it on that as well. Just depends how you want to run the model. And then that block there, for example, touch sensor block, that is one of the BrickPy sensors. Now, like I say, this block up here, when you install Simulink and say I want to use the Raspberry Pi package, that block is there, and you can say, okay, I want to pull video in and do something cool with that. This block is not. So what you have to do is use this thing called the S function builder, which sounds like horrible and complicated, but it really isn't. And when you get the BrickPy, they give you example code, which most things have some C code examples. If you've only got Python, you might struggle a little bit. But if there's some C code examples in there, that's all you need. So you need some C examples of how to interface with this particular thing you plugged in. And then in this nice little box, you just copy the line there. I don't know if you can see that, but it just says BrickPy.sensors and square brackets and the parameter. Which is, I like the back. Somebody's. I don't know if it's appropriate. Yeah, so that's just you assigning the value of that function call to value 0, which is something you define graphically. I won't show you that. If you're interested in all of this stuff, I can explain it to you in more detail. But basically, there's dialog boxes here where you say what are the inputs to this block, what are the outputs from this block, and then you can assign them programmatically with some C code in here. And that all goes into the overall model and gets built into a nice big C project. You don't have to worry about all that stuff. You just need to worry about this one line of code that does the job you want to do. So I've got a couple of those. I've got a touch sensor, I've got an encoder, which gives you the position of the wheels, and then in here, I don't know why it's in a separate box, but it is the motor for driving the motors. Now, like I said, unfortunately this doesn't do anything particularly interesting here for you today. Well, I guess it depends on your definition of interesting. But what we've got coming in is we've got the video coming in. If I show the video display. There we go, famous. Not even paying attention. So that's still not paying attention, no. So that's a live video feed. There's a bit of delay on it because this is coming back through a network. This isn't a screen plugged into the Pi. This is being networked back into the code. And what this code here is doing is it is trying to detect, so that you won't be able to read that. This is detect coloured balls, and this is just a little thing that I've designed, which tries to detect the, what colour is it? It's detecting green, it's the parameter, and it's got a threshold of 60. That's kind of a meaningless number, but you can change it if it doesn't work. So hopefully, if I show the robot green ball, it gets excited and tries to grab it. And that is all handled in this logic here.
So it's going to try and grab you on.
I can make it. You're not really wearing a uniform colour. No, any uniform colour. I can show. Oh yeah, go for red. I can go for red. Let's see if it.
Ooh, it's like that.
No, that's it getting ready to grab something else. Let's see if we can go for red.
We've got a marker pen. Call you red, Alan, can't we?
We'll know if it's identified.
Lots of space here. You could write stuff on.
It'll draw a red cross on you. It hasn't spotted you. You're too
no.
Oh no!
It's got on his face then.
It's on his face.
Oh, you've got a red face. You've got a red ear.
It's got an ear.
You've got.
It's going to pull your ear.
Oh, you're red nose. There you go. I can change the threshold on it and see what else it can do. But yeah, but you get the idea. All this code is running live now. So this is compiled C code that's running on the Pi. It's just been Simulink makes the C code, downloads it to the Pi, compiles it on the Pi, and then runs it. But you can control it while it's running from this window. So I can change these parameters now. Like you see, I've changed it from green to red. And I can also say detect things that are maybe slightly less red, so a lower threshold. Now you're definitely red.
It's about my head.
Yeah.
Yeah? Try it
you've gone.
you've gone.
And then come back on again.
Yeah, that's pretty good, man.
Yeah.
Take the shot.
But what this is actually doing, this is actually looking for, well, you just demonstrated that. This is actually looking for movement. So if you can stay still, and I'll open the jaws. Now if you move, it tries to attack you. So, like I say, it doesn't do the robotic ball boy thing that we did the other week, but it just demonstrates what you can do using using the tool that we have, which is Simulink. We also have MATLAB. I'm not going to talk too much about that today. It's not that relevant really to the Raspberry Pi. If you're interested in it, come and talk to me. This is MATLAB. Yeah, this is a T-shirt with MATLAB code on it. There's something special about this code, and I don't know what it is. I haven't worked it out yet. So that's why they put it on. But what I'll do now is I'll just show you the video. I think I'm still sort of coming out of that. I'll just show you this video of it doing its actual job. But even then, even with perfect setup, it doesn't actually work very well. It nudges the ball out of the way the first few times because it's a bit over-ambitious going to try and grab it. No, fail. Sorry. But third time lucky, it actually gets it, and then you'll see once it's grabbed it, it starts turning to look for Andy Murray, and then it spots him in the background there. There you go. Spotted him now, and off it goes. This is all completely autonomous. And then it notices when it got to the end of the table, it's got a light sensor on it, drops the ball through a hole. We had some drain pipe guttering on the end of the table, so it made sure wherever it dropped it, because it was never going to end up perfectly in front of Andy Murray, it's not that good. So wherever it dropped it, it funneled it down a thing, which then bounced off a tennis racket and tripped a switch to set off some other machine somewhere else. So it was good fun, that was a good day. But unfortunately I couldn't reproduce it here today because the lighting is different. And anyone that's ever done image processing knows that that is a significant problem. I spent a couple of hours this morning trying to rectify it, but then realised that up here it was probably going to be different again, so there was no real point. So I hope I've given you an insight there as to what Simulink may be able to do for you. If you have complicated projects that are really difficult to code by hand, it's something worth considering. It's not horrendously expensive anymore, so feel free to come and have a chat with me. Send me an email.
Oh, what's your email address?
Good point. I should probably have that on the slide or something. I'll put it on Twitter.
Cool, thank you.
There we go. Because if I try and say it, I'm sure it will get misspelled. So I have an annoyingly awkwardly spelled name. So yeah, that's it from me. Thank you very much. Any questions?